My name is Joshua Kugler, for those of you who don't know me, and for those of you who do know me, that's still my name. And I am a computer systems administrator, programmer, automation junkie. Um, I've been doing computers since 1986 when somebody gave our family a Commodore 64, and the sickness and addiction has progressed from there. So recently, the company I am with gave me a chance to set up a Nomad proof of concept because it sounded really interesting to me. And they said, yeah, I don't have anything assigned to you right now. Go have fun with it. I've used Hashicorp products in the past, most notably Terraform and Vault. And so this just kind of extends what I've been learning of the HashiCorp ecosystem. And of course, Vagrant and Packer used that lots in the past. So we're going to talk a little bit about Consul and Vault, and mostly about Nomad. So what is Nomad? Nomad is a workload orchestrator. It's designed to be simple and straightforward. It can orchestrate your containers. It can orchestrate your VMs. It can even orchestrate um, Windows Internet Information Server applications. It's got a lot of flexibility, but it is a workload orchestrator. Um, HashiCorp works on the Unix philosophy, do one thing and do it well. And so Nomad does not manage your ingress egress. Nomad does not manage your storage directly. There are plugins for accessing your storage. Nomad does not manage your secrets. That's up to Vault. I could probably construct a list of the things Nomad doesn't do that you might see in something like, oh, I don't know, Kubernetes. But Nomad is designed to be fairly simple. In learning Nomad and getting into this, an analogy that's kind of become apt is Nomad is kind of like Python. You can do the simple things really quickly, but when you need more functionality, you can dive in and learn new things and extend your functionality and your knowledge as the need arises. An example of simplicity is the same binary that you run on the server that does the whole mesh, uh, mesh and high availability is the same binary that runs on the Nomad client that executes your applications and it's the same binary that you download to your local system and run to talk to the Nomad cluster. And or you can run a Nomad dev cluster on your local system with the same binary by just passing a few, I think it's Nomad -dev, and you'll bring up a fully functional cluster for you to play around with on your local machine. Um, so there we go. Simple and lightweight, easy federation at scale. You can do multi-region, multi-cloud. Um, in this particular instance, I have not set up any kind of security. You can use Vault to be your certificate authority and generate certificates for uh, your clients and your command line. And so that, it's called MTLS, mutual TLS. You verify identity on both ends using certificates. You can set up all that. I am not even running on HTTPS for my demonstration, but I do have it locked down to my IP. So, and then as I talked about, you can integrate with Consul and Vault, and we'll show some of that later. And there are some great Nomad versus Kubernetes articles out there. Pull that away for the moment.
Josh, do you want to say like one line about who, for people who do know Kubernetes, what would be like the most significant distinguisher, like when you might want to use Nomad instead of Kubernetes, or if that's too general, something's more specific.
Yeah, I don't know if I have anything that comes to mind immediately. Nomad is just a lot simpler. I mean, if you know Kubernetes and you're in the Kubernetes ecosystem, that works for you. There, I don't know if you could argue that you should or migrate to Nomad. But if you're looking, especially if you're looking to bring up a new orchestrator, I think Nomad is a lot simpler, and you get up and running, and there's a lot less complexity when it comes to managing your applications. and
Thanks.
in your clusters. All right, so right now my Terraform that sets up the cluster is a fork of their Terraform directory in the Nomad repository. I actually have taken it, extended it, do some additional things with it. I've actually automated it some more. I have added some functionality to the cluster configuration, or to the machine configuration that Packer makes, so that Nomad will actually not start up until a certain file is in place that has the token that it needs to talk to Vault. So I've done some Vault integration here. So far, I run the Terraform. It fails and says, "Oh, I can't start up these jobs. That's because the Nomad cluster is not up." I have a little script that I give the IPs of the servers, and this unseal or inits the Vault cluster and unseals the Vault, and then generates a policy for Nomad, and then gives that, that's the output of T, I should pipe that to null, but it gives that Vault token to Nomad, and then it can go ahead and start up on the various clusters it sits on. And so let's finish applying.
So you've connected to Vault.
And
You've
so
got the
we're
secrets
actually,
necessary to connect each individual Nomad, future Nomad instance to are they clustering together, or are they relying on one of the other HashiCorp components for that? Because I know that Consul is self-clustering, or is Nomad
right. So
specifically clustering with itself?
Nomad clusters with itself. So you have the servers and you have the clients, and the servers you should run 3 or 5. So there's consensus, and they do the scheduling and monitor, the nodes and where things should go. And then the clients actually only talk to the server cluster. The clients really don't know much about each other. Um, and so as we'll see, you
Okay,
can use Consul for various
okay.
things in here, but
So that sounds slightly different from Consul, but the same idea that you need an odd number to keep it
mhm.
alive
Yep.
for HA.
All right, so it finished its apply. It started some applications in there, and we can go take a look at what it's done. So I have a sample API in there. I have a Postgres container running. Oops, dead. It better not fail in my live demo. There are plugins that it uses. Now, these plugins are for accessing. I thought I clicked. I didn't want to click. These plugins are for accessing the storage that AWS makes available. Fabio is a load balancer that is pretty much almost zero configuration load balancer that uses information from Consul to determine where to route things. And I will get to that in a moment. Let's look at Consul. So Consul, 3 instances, is up and going. API sample Python, there are 3 instances of that, and it's live. Hey, look, Postgres was live. There it goes, green, yay. Vault's good, Nomad, the 4 Nomad clients are good, Fabio's good. You see 9 instances of Nomad, even though that's 3 servers, because there's HTTP, RPC, and surf endpoints that it's actually monitoring. So that's why you see that apparent duplication there.
So Nomad is pushing these checks into Consul?
Yes, Nomad is
Okay,
talking to Consul,
got it.
and it's saying, hey, these are the things you should be doing or
Yeah,
should be
because
checking
when
upon.
I was demoing Consul earlier, I was just creating those. I wasn't doing any orchestration. So this is cool. Thank you.
Okay. Yep. Um, and then Vault, I'll maybe I'll show that at the end for a simple dive down. Let's see. Where am I going? Oh, okay. So go dig into some of the configuration. Where is? So here you have the Nomad server configuration. This is like a variable that's replaced, I think, when so you built, excuse me, I'm digressing, but there's a Packer image that is built, and then all this is spun up from that. And so that is, I think, modified when the image comes up. Here's the console that it talks to. Since Consul and Nomad are running on the same server, it just talks to it on the local. The Docker plugin needs an allow privileged to, I believe, is drinking from the fire hose, so pardon me if I get a detail wrong. To connect to the AWS storage, to the plugin, the Docker has to run in a privileged state. And then here is where it runs, or where it talks to Vault. And then it uses a environment file in the systemd unit to get the value of the token that it then talks to. And to clarify, only the servers need the token. The Nomad clients do not. They get Nomad talks to Vault and then gives the clients and the processes that start on the clients what they need. And we can dig into that if there's questions about that later. So my sample API is running this is the configuration. You define things like your data center. You can use that in Nomad to define. You can use that can be like your regions or your that kind of thing. A service is just plain, it brings up an application. There's the rules for rolling out new versions. Uh, let's see. So you define the ports you want to listen on. Um, that's not saying port 80. That is simply a name. That is basically saying I'm going to need a port. Pick a random port that the container is going to listen on and talk over. So you go down here. So you have your Docker driver for your task. There are lots and lots of drivers for different kinds of tasks I alluded to. Um, here's the ports that application uses. It's using the port named HTTP. And then there's an environment variable that is getting passed as an argument to my Docker container called nomad underscore port underscore HTTP. And so this will be replaced with whatever random port Nomad decides. And so so if you actually go and look at the job running in the Nomad console, you'll see that on one client it's listed on one port, on another client it's listed on another port. And so that frees you from managing, oh, I need this port here, that port here. It does that automatically for you.
So then your load balancer
Um,
front end has the config for that pushed into it, right?
yes, and I'll
Okay.
get there
Okay.
yeah, we'll get there. So here is where the vault magic happens. You declare a template, and what's in this, data equals, that can be in any format you want. That can be, the straight key value. You can do a JSON construct in here and have it write out to a file. If you do the straight key value and say env equals true, it will export this to the environment of your application. And so in this case, and you will notice it doesn't really abstract out the details of the API. That was one thing I was fighting with for a long time, trying to get this up and going. The vault policy applies to the actual storage paths, whereas and not the API path. It's interesting. And there's a couple very long threads in the Hashicorp discuss board of me banging my head trying to figure this out. And so you get your user, password, host, and name from Vault, and then it exports this to your environment, and your application will pick that up. This defines the down here. If we say this service is named API sample Python, it's using the port named HTTP, and then I'll get back to the tags. And then here's the check defined for this service that it pushes back to, or pushes over to Consul, that then hits this to make sure the application is live. So you can have any number of tags you want in an application. There's a important-ish one right here, and that's called URL prefix. This is what is picked up by Fabio to determine what path to basically intercept and pass to this particular application. In this particular case, I'm just having Fabio serve everything that is thrown at the load balancer from this application. This goes from most specific to least specific. So you can actually have other applications running under this, maybe like, slash web or something like that. And if you hit it with slash web, it will direct it to the application with the URL prefix of slash web. Otherwise, everything will hit this.
So Josh,
Where did
if I can
my,
ask, why is this a tag? Because I understand that the interaction of tags with console, but why is this a tag versus then say Fabio config? Like, why is this in your
Mhm.
service in the API, your API sample Python?
So Fabio is a zero. Uh, Fabio,
It's a
Fabio.
straightforward reverse
Fabio is a
proxy
zero.
load balancer, right?
Basically, what's that?
It's like a reverse proxy, right?
Yeah, it's an application load balancer that runs on your, and I'll look at the job for it in just a minute here. So basically, it's designed to be as zero config as possible. So you don't really, let's go look at it. You don't really configure Fabio. You say run the Fabio load balancer. Um, you say, you define, there are a couple ports you define so you can get to it. And so you have a static port to point like your AWS load balancer at it. It's a special type of application. It's a type system, which means it runs on all client nodes. And so in this case, we have 4 client nodes running. We have 3 copies of API sample Python. And so the tag that you give to your application is the URL prefix tag that you give to your application is a special tag that Fabio picks up on. So you don't have to maintain a Fabio config of application versus versus your application tags and and all
So
this.
that
And
so
so
that is
this,
essentially shared by console and Fabio then, right? Is Nomad handling that tag specially for Fabio's case?
no, Nomad simply oops, wrong screen. Nomad simply that pushes all those tags. I don't know if I can actually find it this way.
I saw it at the main console service status, but
Oh, you did.
yeah.
See, I completely missed it. Ah, right there. So Nomad simply pushes all those tags to console, and then Fabio pulls the tags from console and looks for that URL prefix and goes, oh, I'm supposed to serve this application at this URL.
Yeah, that makes
And
sense.
so,
So you could theoretically write your own service that relied on console tags and replicate that behavior or modify it in some way.
yep,
That behavior is Fabio's behavior, not console or Nomad's behavior.
yep,
Right.
yep.
It sounds like the
Awesome.
answer to your question is that Nomad doesn't know what Fabio is,
Right.
but
Right,
Fabio
right.
work.
Nomad has no concept of what Fabio is. It knows it's a service running on it. So there's the main page. If you hit the API URL, this uses Flask and Flask RESTX. and you can annotate your application, and you get a nice API browser, model browser, get to play around with the API right in there if you want. Where am I going? Okay, so, these are obviously all the jobs that are running. There you see the Fabio job, again, the storage. So you can take a look at your clients and your servers and your topology. It says too much information. This is not live updated. How much of your memory is used, your CPU availability, and then it shows where your various applications are running on your various clients. If we take a quick look at the Postgres Nomad command, let's see, where's the one? So this is an example of using external volume. You provision, sorry, I have to look at my code again.
Like an
You
EBS volume or
provision,
something?
yes, it's an EBS volume you provision. You give it a name, and then you tell Nomad they can use that volume, and then you say, hey, this job is going to use this volume and mount it at this location. And then I could add data to my API, kill the Postgres instance, bring up a new one, and it would all be there. So I'll give a quick demonstration of that that tagging and URL thing. If I run, so I can, this is from my local system now. I've exported the endpoint of the Nomad server. Pretty sure I have. I'll double check that I did. So if I do Nomad run, and I have here an HTTP echo image. It's a little Hashicorp Go image that just uh, echoes out whatever string you pass it. And again, we have that pattern of HTTP port and whatever port it wants to listen on, and then we give it a path of HTTP echo. Nomad run HTTP echo nomad. It's now scheduled it, and we see it already running. And so if I go back over here to my load balancer and I do HTTP echo, and so even though the other application has a URL path of /, which should be everything underneath it, Fabio is smart enough to recognize, oh, this is more specific. I'm going to match against that instead. And if we go to Consul, and we see HTTP echo is registered with a URL prefix of HTTP echo, and it's up and it's live and it's healthy. Let's see. I think, yeah, that's the, as far as my presentation and simple feature walkthrough goes, that's it. I would be happy to field any questions I can answer, which may not be a lot because I'm new to this too.
So do you need to, so you have 3 servers and you had 4 clients.
Mhm.
So does that mean that this whole process brought up 7 different EC2 instances?
Yes.
And is there a way, I mean, can you just have one Nomad server? Like, I know this is a lot lighter weight than Kubernetes, but is there a way to do this even more lighter weight, I guess?
You could, yeah, you can do one Nomad server. It's supposed to be an odd number for consensus. You could do one Nomad server. I don't know if you would want to deploy to production that way. They probably wouldn't recommend that. It's the reason they do multiple is for, high availability, and if one does die, you still have the orchestrator that will talk to all the clients. But these, I mean, it doesn't take a lot of power to run these. I think I have these configured to be running on T2 mediums. And so they're fairly inexpensive to run. And if you're to the point where you're stressing out your Nomad server instances, hopefully that means you're you're making money,
Right.
because yeah, they have a, I need to go find it, but they have a 2 million container scheduling test they did, and it's across multiple regions, multiple availability zones, and they're still running like fairly light, not heavy hardware, but
If it's like their other stuff, it's pretty lightweight.
yeah, yeah,
So
definitely.
can you show us what the Terraform setup is?
Sure. So I mean, I'll go back to this. There's a big module that they give you called Hashistack, and it brings up a lot of this. So something I learned about Terraform that was kind of cool. You can initialize a provider based on the output of a module. So the address of the Nomad server, it basically waits until that part is done and it has an actual UI address. I thought that was cool. So quick rundown of this is like resources to start up a job. You path to the Nomad file. I do some depends on here because there's some things I want to wait for. Ideally, I should split this into like a phase 1 and phase 2, but that hasn't happened yet. Resource for Nomad plugin. This is a AWS plugin, like the base plugin, and then there's a Nomad volume that tells it to use this AWS plugin, and here's the volume ID, etc. More Nomad jobs. Okay, so module Hashistack up here. So there's security group for the server. There's security group for client. Another security group overall. Let's see, template user data. Oh, so that's the user data for a client node. And then you bring up a server. So a lot of this logic, so this is just bringing up the infrastructure. A lot of this logic is contained in some shell scripts that are used in an image that you make with Packer.
Okay,
So
so this all depends on setting up that image.
yes.
But
So like root block
once that's
devices.
done, but that's essentially like a create and forget, and doesn't
Right,
maintain any state. That's just getting it
right,
bootstrapped. Okay.
right. So here's the Packer. 37 lines of JSON. It during setup, it configure. It does initial install of a whole bunch of things. That's the creation of
Nomad
the image.
console.
And
Oh,
then
okay.
there is a client SH that is run on first boot for the client machines, that basically puts configuration files into place, replaces IP addresses or whatever needs to be done, like server counts, and then similarly for the server side, enabling things. And since we're here, so there was another Hashicorp repository that I found that I was able to glean some things from. You create a Vault token ready service, and it runs the Vault token ready. And basically what it does is it sits there and it waits for secrets Nomad server token to be written, which is an environment file of Vault token equals that Nomad token I created during boot up. And you have your target that it waits for, and then in your Nomad service, you can say requires Vault token ready target, wants Vault token ready, etc., etc. And so during startup, it'll run that Vault token ready service, and then it'll also initialize this service but this service will not be able to continue until the Vault Token Ready service exits, and the Vault Token Ready service will not exit until that file is in place. And so that init cluster sh file that you saw me run writes that out, and then it starts and it gets that Vault token from the environment and starts up, and then the Nomad cluster can talk to Vault and get all the secrets it wants from it.
So what all does that init cluster script do?
Okay, I'm glad you asked.
Seemed like the next.
Yes. So let's see. So first thing you do, so it just takes the servers. In this case, I have it hard coded, the 3 servers on the command line. It initializes the Vault. So when you start up, Vault is not initialized. So here, this is very insecure. Just so you know, there's only 1 key share and only 1 key share threshold. So what you do in Vault is, when you init the Vault, ideally you have, well, whatever your company requires, but say you have 5 key shares, and it'll generate 5 keys, and then you say your key threshold is 3, and then so you need 3 of those keys to unseal Vault whenever it gets started. The idea is Vault is intended to be a very long-running service. It is not designed to go up and down. There are ways to automatically unseal, but then you're getting to, okay, what's the point? You know,
Right.
that's the discussion with your security guy. And so in this case, I just have 1 key share, 1 key share threshold. So I initialize Vault, spit that out to a file. I get the unseal key out, and I get the root token, which in this case, oh yes, I do use, obviously. Okay, and then it cycles through all the servers and unseals the Vault using the unseal key that we just generated. And then what I'm doing here is I'm creating a path in Vault that is named secret, and I'll pull up the API or pull up the web browser and show you. And then this is the type of store. It's KVV2. It's a simple, I think, on disk key value
Values, oh,
store. You can have all kinds of backends. You can use a database. You can use other things. And then right here, I'm doing Vault KV put, and I'm adding my, yes, I know, they're in plain text and you see them all. But my Vault, this is my database credentials that I will use, that are then also passed to the Postgres container when it comes up, and it creates a user with this username and password. Oh, and something else that's neat to show here is this is the address of my database. It's postgres.service.consul. Consul acts as the DNS server for the cluster. You start it listing on port 53, and it's running on every node. So all the nodes use their local they're actually they use the Docker gateway address as their local DNS server, and then Consul has also configuration to do upstream. So if they ask for google.com, they'll still get that. But if they do, you can just tell your cluster that your database is on postgres.service.consul, and it's there. So if Postgres dies and comes back up on a different node, the address is still
valid.
postgres.service.consul.
Josh, I was
And
wanted to ask, and tell me if you want to postpone it, the answer to this question, but it was, since I was clear on what, Consul for the internal DNS, how would you be using Nomad to manage external DNS, or would that be something that is like a shim with Consul? Because I haven't gotten that far in my Hashicorp discovery. So how would you actually make this live, quote, live on the internet with a persistent, say, non-AWS DNS endpoint name? But feel free to defer that if you want to finish.
yeah, let me think about that, because I think I know how I want to answer that, but let me think about that. So the next thing I do is I write out a couple policies and roles that Nomad is going to use, and then to talk to Vault, and we can go look at those in a minute. There's a database policy that basically gives the database, or the excuse me, I think both the
There's
container
host
and
control
the
list.
application. Yeah, it's basically saying you can look at secret/db and anything under that, but nothing else. And then we create a token for the Vault server itself that is based on the Nomad policy, and then that enables Nomad to talk to Vault and get secrets. We pull that out, extract that from that JSON file, and then here is the login to each server. Write out this file to Nomad token server, and then as soon as that Nomad token server file is there, Nomad starts up and pulls in that value. Nomad cluster role, that's defining, so this, basically the disallowed policies basically says no application can start up and say, hey, I'm going to use the Nomad server role. You can also do an allow list if you want, but then obviously you're getting a lot more specific. So right now this is just disallow. You can't use the Nomad server role. I need to read again what the orphan means. Basically, basically it allows, if the parent policy or the parent token gets revoked or expires, should this policy or token get revoked or expire. And orphan true means parent stuff can expire or get revoked, but it keeps this. There's the period, renewable, yes, allows Nomad to do its own token renewal. Database policy, path secret, it can list. Basically, that is, if you're thinking POSIX, that's the execute permission in a directory. You can list the things in there, but can you actually read anything in there? And that's what we want for the database is data db config, and then it can read anything under that directory. Nomad server policy. I can't give you a lot of insight into these because these were just from the documentation, and it says this is what you will need for Nomad to integrate with Vault. So pardon the lack of information there. And so Jeremy's question, what would you do if you were doing just like, now you mean like, are you thinking like on-prem, or are you?
Well, no, this is, so it's, the way this API is now running, but let's pretend that this is a public facing service as opposed to like an internal API. So I want to actually make this
Right.
accessible on a persistent DNS.
mycompany.com.
Sorry, Emil?
Oh, like at mycompany.com.
Right.
Oh, okay. So you want your API visible. So right now I'm using so right now this is an AWS load balancer. And so that right now the AWS load balancer is pointing to the Fabio ports, which is 9999 on all of the Nomad clients.
Okay, so it doesn't really matter what clients run it,
Right.
because you could have far more clients than instances of Fabio, for example, depending on what you're doing.
Well, no. Fabio, well,
Are we must run on all of them?
well, as currently can, well, so you can't tell Nomad.
Fabio gets you persistent. It gets you your persistent port.
Okay,
So you just run your Amazon load balancer at this group then, right?
Yeah, you can't really tell Nomad run Fabio on this node, and this node.
Because otherwise you're
really
yeah. It's
you're
the translation from
agnostic.
dynamic
It's just,
ports to static ports, which then gets you, your Amazon load balancer is just pointing at all of them.
right. And so I'm not sure what the mechanics is. I haven't like dug into the code or really that deep in the documentation, but so I'm running four. I'm running.
Well, the Amazon load balancer is going to have
instances.
a persistent. It's going to have a persistent record.
Yes.
It's going to have a persistent
and then
endpoint. So
and
you
then
just
if you
point
bring
at that and you're good to go.
Yeah. And then if you bring up, new clients, then you have something in your automation that adds that client to the load balancer. So I'm running 4 Fabio instances, but because I have 4 clients, but I'm only running 3 API instances.
And that's totally fine because it's using Consul to figure all that out.
Right. And so
Yeah.
I assume that if I hit an instance of Fabio that doesn't have,
Doesn't matter. It'll go to whatever the closest.
go talk to the server that
Yeah.
does.
So worst case
let's
scenario, you do some like
see.
regionality and you'd say, I want this traffic, I want my load balancer traffic to, you know, like these Fabio instances need to only ever point at this region, that sort of thing.
Right, right. Take a quick look at Vault. So you open up and this is, I created that secret store. It's a version 2 KV store, and you dig down in that. There's your DB, there's your config, and there's all that information. And so if like I showed in the permissions, if I want to be able to view those secrets, I have to give the service a policy that allows them to read and not just list the directory. And so, yeah, getting back to your, okay, so I guess I answered your question, Jeremy.
I believe so. I was thinking that there was some
Okay.
dynamic element, and there doesn't need to be because your Amazon load balancer is the dynamic element.
Right. And so if you're familiar with Kubernetes, Fabio is kind of your ingress service. It allows the outside to talk to the inside, and I mean it's literally zero configuration. You put that prefix in your application tags, and that's it. I mean, you don't even there's no like ingress YAML that defines it. It's one of the things I'm really liking about. So I will admit, I don't have a lot of exposure and experience with Kubernetes. I do have more exposure than I'd like to the configuration files required for Kubernetes. And just working with Nomad is like, oh, this is really easy. This is simple. Oh, I just do this and bring this up. Let's see. So as far as scaling goes, for servers, you don't really scale the servers. That Nomad is really quick and really lightweight. And so if you basically, all I've seen referenced in the documentation is 3 servers. If you really need it, you can run 5. But there's never been anything about scaling, building out more servers because of load. When it comes to clients, you might need so you can scale your application across nodes. You start on 2 nodes and you need it to scale more. There's auto scaling policies and to do that. Then you can also scale out your client nodes themselves. And again, there's configuration to deal with that once you want that and need that. Again, it's the whole, use what you need right now and learn more as you need it. And then if you want to pay for the enterprise version, it will actually do like, it'll store metrics and learn the history of it. Oh, there. It evaluates processes and stores historical task resource usage data. And so it will make smart recommendations for you about CPU and resource parameters so you can scale more effectively down the road. Let's see. Oh, and tasks. What can it run? It can run Docker. It can do isolated fork exec, which is basically almost a container. It's basically, I think, LXC it uses. It can do Java processes, Podman, QEMU if you want to do full virtualization, a raw fork exec of a binary, and then there's a whole bunch of community plugins. I don't even know what Firecracker is. But like I mentioned, there's the Windows IIS plugin to spin up your IIS applications. And then let's see, device. Oh, there's NVIDIA pass-through if you want to use your NVIDIA cards inside your containers, and they're working on USB pass-through for that. So that is about the extent of my knowledge at the moment. Again, if you have any questions, I can certainly try to answer them. Otherwise, that's it for
Really quick
me.
one. I know this is backtracking a little bit, but I got
No?
distracted. The load balancer is set up with your Terraform config, the Amazon load balancer.
Yes, yes. Let's see. So after I spin everything up, I go down. Oh, you know what? I think I added that. Yes, I did. Okay, I added that to the Hashistack file. This is like completely mutated from what they originally gave me. But so I actually did 2 load balancers. One is the server So you can talk to the Nomad web interface, the Vault web interface, the Consul web interface. And so that's this one right here that listens on the 4646 is Nomad, 8500 is Vault, I think, and 8200 is Consul. And then the client load balancer listens on 99998, which is the Fabio UI, and then the Fabio data, shall we say, is 9999, and so that's what I converted into port 80, and that's where I was, accessing the UI and the API and that kind of thing. I
And
okay,
this, so
and
you added this stuff to HashiStack? Does HashiStack
yeah, so,
is a thing and you added these things to it?
yeah, so
That's something you'd be willing to share?
yes, I actually I need to clean this up a little bit, um, and I was going to push it to a public repo, and I definitely will make that announcement when I do. So what I forked from is, like I said, the Terraform directory and the Nomad repository, and so shared is all these config and scripts that I do, and then AWS. Originally it was US East. I'm running in US West just because it's cheaper and I don't know, closer to me, probably milliseconds, but and then so the module, the Hashistack is something they give you, and then yeah, that's originally 325 lines. I'm up to 460, so that tells you anything about about what I've fiddled with and added and learned along the way. And so
So minimal
and then
config is definitely relative. You have to get all these pieces in place.
oh yeah, I mean, I wouldn't run production on this because, like I said, there's no SSL, there's no MTLS, there's no verification. I mean, you could restrict by IP, I suppose, but yeah. And then my main.tf is less than 100 lines because I rely on the Hashistack. But yes, Emiel, I will get this cleaned up and pushed up to a repo hopefully soon here.
That'd be very cool. No rush on my account, but that's really neat.
And if you don't already, look into AWS Vault. It is a really cool tool for using multiple AWS accounts. You add your Vault credentials and it can store it securely. It can use the Mac keychain. It can use the GNOME keychain. It can use the KDE wallet. And so I can just say AWS Vault exec. In this case, it's my me profile. It's my private AWS account. And then it'll export all and if you're using two-factor, it'll prompt you for your two-factor ID. Using a key, no, you can't see that because I'm sharing my screen, but using like a YubiKey or something is a little more involved, but if you're just doing the 2FA virtual device, it's really easy. And then it creates a session, exports those variables to the environment, and then you can then whatever you run gets those variables, and it makes it so much easier. So there we go. That is
Thank
an
you, Josh. That was
overview
cool.
for yes. Thank you. I've enjoyed it.
Any last questions?
Before I destroy the cluster. Alrighty. Thank you all.